Hi everyone, welcome back. In our last class, we started computer vision and we have completed our first chapter, that is the convolutional classifier. And today we are going to study about convolution and ReLU. Okay, so let me first read it, then we will do the exercise. So in the last lesson, we saw that convolutional classifier has two parts. If you remember, it has two parts. One is base, another one is head. Why convolutional layer is used? To identify an image. You will be given an image and you have to tell what is the type of the image. Is it a car? Is it a bus? Is it a truck? Is it a boy? Okay. So for that you need convolutional layer, CNN. This is the convolutional layer and it has two parts. One is base part, another one is head part. Base part is used to extract the important features from the image. And head part will classify the image. That means it will tell you what is the type of the image. Okay. Now in today's class we are going to understand what is there inside the base class. Okay. So this is our main job today. Now see, in next few lessons we are going to understand about two most important types of layers: convolutional layer with ReLU activation and maximum pooling layer. In lesson 5 you can create your own coordinate. Okay. So first is feature extraction. This is the best part to extract the features. So you have to learn how to extract the features. This is the input image. Okay. So first we will understand what is the purpose of these layers. We are going to see how these layer operations are used to implement feature extraction process. So feature extraction is performed by three basic operations. One is filtering the image, detecting and then condense. See, first you are doing the filter. So you can see that you can understand what are the edges. See, these are the edges, right? These are the edges. Then you detect. Okay. And after that you do the condense. See, filter is done by convolution. Okay. So you are filtering the image. Second, you are detecting the feature within the filtered image. That is done using ReLU. This is the ReLU part. Next, you are condensing the image to enhance the features. You can see this image and this image. Here, the things are more enhanced. This part is done by maximum pooling. Okay. So, three steps. One is filter, detect, condense. Filter is done by convolution. Detect is done by ReLU. Condense is done by maximum pooling. Okay. Things will be more clear. No worries. The next figure you can see, these are the figure we have seen already. Now that network will perform several extractions. It's not that it will do only one job, but it will perform several extractions from the single image. So it's not uncommon for the final layer to produce 1000 unique visual features. Okay. Now the first one is filter with convolution. A convolutional layer carries out the filtering step. You might define a convolutional layer in Keras model something like this. See this one. From TensorFlow import Keras. From TensorFlow.keras import layers. Okay, these are the things you are importing. Here your convolutional layer is defined. So next is you are creating the model. So layers.conv2d filter equal to 64, kernel size equals to 3. Now let's understand this part. See, first you are given the image. Image means this is collection of pixels. That is values. So I can write, let's say 1 2 3 2 1 0 1 2 1 0 3 2 1 2 3 1 0 1 0 1 2 1 2 1 2. Whatever value you want to take, you can just take. Okay, this is your image, or I can say input. Fine. Next you take filter, or we can say kernel. See, we have said. So you are taking 64 filters. And what is the kernel size? 3. So I have taken 3 by 3. 1 2 3 1 2 3. 3 into 3. Right? Now what will you do? Now you have to impose this complete part on this part. And there will be a matrix multiplication. So let me show you one. So first part will be 1 2 3 0 1 2 3 to 1. This portion into 0 1 0 1 minus 4 1 0 1 0, this part. Okay, now what you have to do? You have to do the multiplication. You know how to do matrix multiplication? This way, this way. Then you will never get confused, right? So I am taking 1 into 0. So 1 into 0 plus. I said this way, so you have to take this one, 2. But here I have said in this way, so you have to take this one into 1. Now 3 into 0 plus this way, second column this way. So first is 0 with 1, 0 into 1. Next is 1 with minus 4. So 1 into minus 4. Next one is 2 into 1. So 2 into 1. Okay. Plus this row, last column. So 3 into 0. 3 into 0 plus 2 into 1. 2 into 1 plus 1 into 0. 1 into 0. So if you add them, let's say you get x. You get my point? This is how this is done. Why, that you will understand later. Let me first explain how. So your output will be, let's say, x. Okay. Now what you have to do? Now you have to take these three values with this image, with this filter. Okay. So next time it will be, show you one more, 2 3 2 1 2 1, this portion, the blue one. Okay, 2 1 2 with the filter 0 1 0 1 minus 4 1 0 1 0. Same way multiplication will be done. Let's say the value will be y. Clear? Now you have to move by one row. So this 3, it will be multiplied with this one. Let's say you get z. Clear? Next you have to come here and you have to take 3 by 3, this part. So let's say A. Again you are moving by 1, so this portion, so it will be B. Second, next it will be this one, let's say C. Done. Now again you have to take these 3, so it is D. Now you have to take this much, E, and now you have to take this portion, let's say F. Okay, so see, this was the image input, this is the output. Clear? This is how the operation is performed. Now let's read more, things will be more clear. Okay, so kernel size equals to 3 means you are taking 3 into 3 size. Okay, and filter 64 means you are taking 64 filters. Fine. Now we can understand these parameters by looking at the relationship to the weights and activations. Weights. The weights of a coordinate layer during training are primarily contained in the convolutional layers. See this one. This one. Convolutional 2D. Here the weight is contained. These weights we call kernels. Okay. And it looks like this. Fine. Now see, kernel operates by scanning over an image and producing a weighted sum of pixel values. See, that's what I have told you. You are just taking this one and you are scanning over the image slowly and you are producing this output. A kernels define how a convolution layer is connected to the layer that follows, and it can be of any size. Especially odd number dimension is better, but that's not a requirement. Like we have taken 3 by 3, same you can take 5 by 5. Odd one is better so that one pixel sits at the center. Okay. Now next one. The kernels in convolution layer determines what kinds of feature it creates. During training, a kernel tries to learn what feature it needs to solve the classification problem. This means finding the best value for its kernels. Okay. So while training, it tries to learn that which one is giving you a better solution. Okay. So that it is actually finding the best values for the kernels. Activations. Activation means the activation in the network we call feature maps. These are feature maps. Okay. These are the result when we apply a filter to an image. You have applied different kinds of filter. So this is one feature map, this is another feature map, this is another feature map. These are the pixel values and these are the pictures. Okay. So here are few kernel pictures with feature maps. Okay. Now from the pattern of numbers in the kernel, you can tell the kinds of feature maps it creates. Generally, what a convolution accentuates in its input will match the shape of the positive numbers in the kernel. The left and middle kernels above will both filter for horizontal shapes. With the filters parameter, you tell the convolutional layer how many feature maps you want it to create as output. I told you that we have given filters equal to 64. That means you are getting 64 feature maps. Clear? So you are doing filtering using 64 filters and you are getting 64 pixel values with 64 feature maps. Clear? With the filter parameters you can tell. Now detect with ReLU. So as of now we have completed this part. Filter an image for a particular feature. Clear? Now let's move to the detect part. That is done using ReLU activation function. See, after filtering, these feature maps pass through activation function. The rectifier function has a graph like this one. This one is the ReLU function graph. A neuron with a rectifier attached is called a rectifier linear unit. This is the full form of ReLU. Okay, there is a rectifier. For that reason, we might also call the rectifier as ReLU function. The ReLU activation function can be defined in its own activation layer. See, this one is here you have given activation is none. There is no activation. But the same thing, you have just changed the activation equal to ReLU. Okay. The same code you can see. Keras.sequential convolutional layer giving 64 filters, kernel size is 3. You are just adding activation equal to ReLU. Fine. Now you could think about activation function as scoring pixel values according to some measures of importance. Now the ReLU activation says the negative values are not so important. So sets them 0. See, these are the feature maps. You have got it from convolution and these are the pixel values and these are the feature maps, right? See this one, these three, you have used 3 filters. Fine. Now ReLU says that you have got some negative values, see -2, -1, -1, -1. So ReLU says that these are not important. You don't need any negative values, but replace them with 0. So like other activation functions, ReLU function is a non-linear function. There are many other activation functions. Here we are talking about ReLU function, and the job of ReLU is to make the negatives as 0. So that's why the graph is like that. There is no negative value you can see. If anything is negative, it will be 0. Okay, only positive values will be remained and negative values will become 0. That's why the graph is like this only. Okay, now let's do an example. Let's apply convolution and ReLU. So we will do the extraction ourselves in this example to better understand what convolutional networks are doing behind the scenes. This is the image. Okay, now see. For filtering step, we will define a kernel, then we will apply it to the convolution. Right? The kernel is in case the age detection kernel. Kernel helps us to detect the ages. You can define it with tf.constant, just like you would define an array using np.array. See, import TensorFlow kernel equal to tf.constant and you are defining your own kernel. Okay, this is the figure size is 3,3 and show kernel. See, this is the kernel. Okay, now TensorFlow includes many common operations performed by tf.nn module. These two we will use conv2d and ReLU. Okay. So next, hidden cells does some reformatting to make things compatible with TensorFlow. If you want, you can just go through this. This is for image and kernel. Now let's apply the kernel. See, tf.nn.const2d. These are the function. This will help to apply the kernel. Input is the image. This one is our input. Filters equal to kernel. This is our filters. Strides equal to 1, padding equal to same. These things I will tell you later. And now you are taking the figure and you are getting this output. This is your filtered image. Okay, so here you can see you have applied convolutional 2D. Next step, adding the ReLU function. This function is much simpler than convolution as it doesn't have any parameters to set. So here you just have to write tf.nn. tf.nn, as they have told you, that some operations performed by tf.nn module, right? Again, you are using ReLU. So plot figure, the same figure, show the image, and now after activating ReLU. This was before ReLU, this is after activating ReLU. So what it has done, from these feature maps, the pixel values, negative pixel values are transformed to 0. Okay, only the positives have given the priority because ReLU thinks negatives are not required. Now we have created a feature map. Images like this are what the head uses to solve the classification problem. We can imagine that certain features might be more characteristics of cars and others are in trucks. So the task of a coordinate is to create kernels that can find those features. Okay. So we saw in this lesson the first two steps, a coordinate, filter with contour layers and detect with ReLU. So we have completed these two parts. One is filtering, another one is detecting. Okay, so filter will give you some feature maps and ReLU will remove the negatives, make them 0 and keep the positives. And in our next class we are going to understand the third part. Once you understand all of them, then you complete this particular base part. Okay, now let's do the exercise. In this exercise, you will work on building some intuition around feature extraction. First, we will walk through the example we did in the tutorial, but this time with a kernel you choose yourself. We have mostly been working with images, but what's behind all of the operations we are learning about is mathematics. See, first let me run this to get started. Then you have to apply transformation. The next few exercises walk through feature extraction just like the example in the tutorial. So let's run this. Now import, you can run this cell to see some standard kernels used in image processing. See, kernel, edge, serpent, these are the different kinds of kernels. So see, this is the gray image and these are the different types of kernels. Okay. Now use the next code cell to define a kernel. Now this is your job. You have your choice of what kind of kernel to apply. One thing to keep in mind is that sum of the numbers in the kernel determines how bright the final image is. So generally you should try to keep the sum of numbers between 0 and 1. Though that's not required. In general, a kernel have any number of rows and columns. For this exercise, let's use a 3x3 kernel which often gives the best results. Define with tf.constant. So see, it is better that you keep the sum of the numbers between 0 and 1. Okay, so let's take the kernel from here. This is how you have to define the kernel. So let me just paste it here. And we can change the numbers. Let me give -2. So -2, -3, -5, -6. So let's give 1, 0, 2, 1, 2, 3, 4, 6, 1, 7. So -6 plus 7, it will be +1. Let me run this. See, correct. So you just try to keep the numbers between 0 and 1, though that's not mandatory. Okay. This is how you can define your own kernel. You have to just give 3 rows, 3 columns. Now let's uncomment to view the kernel. You just have to uncomment this one. See, now it is fine. Okay, this is the kernel you have given. Okay, now we will do the first step of feature extraction. First, run this cell to do some reformatting for TensorFlow. Fine. Now we will apply the kernel to the image by a convolution. The layer in the keras that does this is layers.conv. You do know that what is the backend function in the TensorFlow that performs the same. We have already read tf.nn. So the backend function is tf.nn.conv2d. Okay, but you don't need to write this because uh, Keras is already doing. You can just use layers.conv2d. Okay, but this is the backend function. Fine, let me run this. Fine. Now once you have got the correct answer, run this next code cell to execute the convolution and see the result. See, this is the image filter. You can see input is image, filters equal to kernel, strides 1, padding same. This is the image show. But there is a problem. Why? Okay, now apply ReLU. Now detect the feature with ReLU function. In Keras, you can do it conv2d. There you can write activation equal to ReLU. But what is the backend function? It's same. For both case, it is tf.nn.module, that is ReLU. Okay, now let me run this. Okay, now once you have got the solution, run the next code cell to see the image. This is the image after activating ReLU. Before, after. Okay. In this tutorial, our discussions of kernels and feature maps was mainly visual. We saw the effect of conv2d, convolutional layer, with ReLU activation function by some images. But the operations in a convolutional network, like all neural networks, are usually defined through mathematical functions, through a computation of numbers. In the next exercise, we will take a moment to explore this point of view. Let's start by defining a simple array to act as an image. See, this is a simple array, but no image is showing. Observe convolutional on a numeric. What do you see? The image is simply a long vertical line. I can't see any image. Is there any image? But where is the image? A long vertical line will be the image on the left and a short horizontal line on the lower right. What about the kernel? What effect do you think it will have on this image? You can think that how the pattern of positive numbers will tell you what kind of features the kernel will extract. The kernel has a vertical column of ones, so we could expect it to return features of vertical lines. Now let's try it out. Run the next code cell to apply convolution and ReLU to the image and display the result. Here the image is not showing, I don't know why. In this lesson you learned about two operations. Okay, we have got the main point, that is filtering an image with a convolution and detecting the features with ReLU, rectifier linear unit. And in the next one we are going to read about condensing for using maximum pooling. Then our best part will be completed. Okay, so meet in our next class. Till then, bye. Happy learning.